Hi, this is Kelly Williams on the CST for New Mexico, and I figured I'd make a little tutorial video on how to make the new approved version of the PR2 Data Viewer, which was made by Paul Brantmeyer, one of the instructors at FIBWA and the old Virgin Islands, NIMSO. A lot of questions from other operators that I know about how to use this, and figure maybe this will help you out. So some of the features of this program are that unlike the MSD Discovery Workbench, it gives you a customizable plate layout, and it's recently been certified for use by Signature Science for PAT rounds, and it uses the same source code as the MSD Discovery Workbench, and that's been certified in this version. And so you'll get the same results as you would with the MSD program, which is in a fixed format. However, unless you've learned this program from someone else that has been to FIBWA, you're only going to know how to operate it unless you have attended that course, and that's a downside. So a lot of the FIBWA graduates kind of have a leg up when it comes to using the software, which is really powerful. So one of the issues with the MSD Discovery Workbench is that it comes with this fixed template, as you find in the ST, but if you want to deviate in any way, it doesn't really fit. And so there are a lot of ways that you can use the PR2 more powerfully, more effectively, and not waste rows on your plates and get better results. This is not a FIBWA method, as they would say, but it's just a way to use it more effectively. So I'm going to walk you through a sample run, and this is what I'm going to need to have set up in the data viewer in order to analyze this run properly. I'm going to run 5 dilutions from neat all the way down to 1 to 1,000. I'm going to have 2 positive controls which are multiplexed instead of having positive controls for each agent. The positive control multiplexing was also recently approved by SIG Science. I'm going to run separate inhibition binding controls for each of the agents, 2 contamination control samples, and 4 PBS only negative controls. So we need 24 wells in this run. And as you'll see here, the way that I'm setting it up is I know that I've already used the first row on this plate, and that B and C are the next open rows, and these are my 21 wells that I'll be using. And we've got these 3 empty wells here. So we're going to set up from most concentrated down to most dilute, my positive controls, the IBCs, contamination controls, and the negatives. So we'll get right into it. First of all, if you don't know how to get the PR2 Data Viewer, it's under CST DataNet, under the downloads section, under ISO, down here at the bottom. This is the version. 3.0 was not approved by SIG Science, but 3.1 had some necessary improvements to it. So that is it. And then once you download it, it will run as an executable, so you don't have to install it on government computers. You can run it as this executable, which is a great idea by Paul. So I'll just walk you through it. You have to click here to recognize that Paul is awesome. The tabs are set up logically from left to right in order of what you have to do. So the first step is to open the text file from your PR2 run, and it will show general results for all the wells. We are only going to be focused on these wells. So the shared controls group is already defaulted in the program. We're going to add a sample group. So with the wells, since we can tell the program what these wells are to us, whether it's an unknown, a positive or negative control, a contamination control or an inhibition or matrix control. We have to go in and do that now. This is probably the most important part of analyzing a run. So we know that the first 10 wells of row B are unknown wells for us. So highlight them, click well properties. We're going to call it unknown. And the experiment type is unknown. Next we'll get into some of these other types. And it is in the S1 group. And so then you can see out of all this, it is now named these unknown, and it's put them in the S1 group. These two are positive controls, and they are in the positive experiment type group, shared controls. These three are inhibition binding controls under the inhibition experiment type, and they're in the sample group because they are not controls. These are contamination control wells. We will leave it in unknown and put it under S1. Back under the IVCs, I forgot to name them based on the agent. So this is IVC bot SCB and ricin. And this contamination control was from my benchtop. This was from my glove box. These four wells are negative controls, which contains just the PBS, and they are in the shared controls group. So now if we look at the wells that were utilized during this run, you can go back and see we got the unknowns here. I need to change the names based on the dilutions. We've got the positive controls that were multiplexed, and inhibitions, contamination controls, and our negatives. If you don't know about multiplexing positive controls, there are some email strings from Sig Science about that. It's been approved, and it just makes sense. So check that out. So these two are neat. So I'm just going to amend the name. These were my 1 to 2. One to 10. 1 to 100. 1 to 1,000 dilution. So now they should all be correct. Yes. Alright, then we have to calculate the thresholds for our controls group and apply it to the sample group. So here's where it's taking the positive, negative controls using the algorithm from the MSD Discovery Workbench and applying it to our sample groups, the S1. Add analysis, doesn't matter what you name it. And select it and click Analyze, and it'll generate a PDF with the results of your run. This is really what we're wanting to get to. Won't go over the math, but this is where he's showing you how everything was calculated. Alright, so we started with B1, so we can see the neat and the 1 to 2 dilutions are positive for ricin, that the PCH and L controls are within our limits. And then again here on the 1 to 10, positive for ricin. At the 1 to 100 and 1 to 1000 dilutions, we're not above our threshold for a positive hit on ricin. Let's see, inhibition, we see the ricin and the bot on the IBC bot. On the SEB, we see the SEB and ricin. The IBC ricin, we of course see the ricin. So we're looking here, and it looks like it is not inhibited. Contamination controls are both good. On the negative side, still looking good here. Positive control, looking good. The other positive control, also good. The remaining negative wells look exactly as they should. So it's a good run with a final call for ricin at the neat through 1 to 10 dilution. At this point, you can export as a PDF and save it wherever you like, so that you can use that in your PAT submission or your closeout packet, or however you like.